Here we have ticket number 12589, and it's a faulty PlayStation 5 that doesn't power on. Well, actually, that's quite a lie. It beeps as if it goes to turn and power on, but then just doesn't do anything. When you keep pressing the button, every second or two, you will constantly get a beep, but the machine doesn't display any blue LED lights, nothing like that. It is just a beep sound that you hear. I will caveat this by saying that apparently the unit has been looked at before, and a shop just went ahead and confirmed that it was indeed a motherboard issue, and they didn't do anything else. Today we're going to find out if that's true and see whether they've actually done anything to the board itself, and obviously try and fix the console. I've already checked for 12 volts. I'm getting 12 volts in, so I know that the power supply itself is okay. Very quickly, again, based off experience with these sorts of issues, I'm just going to check around this is the back of the Wi-Fi IC, just to see if we have any shorts on any of these caps. So it can be a quick telltale sign. But nope, all of these caps seem to be okay. Next then it's over to the fuses, just to see if we have continuity or any of them have blown. That one's okay. That one's alright. This one here, F7003. That's also okay, we get continuity. F7502 just here. We also get a continuous path. F3501. Also okay. And finally for this side, I believe it's the last one, is F7501. Which is just here. Make sure that we have a continuous path, which we do. Okay. F7001 over here as well, when it's lonesome. Just check this one. Yep, that seems to be fine as well. Okay, so all fuses seem to be continuous, which means they have not blown. There's also one on the back of the board. This is a 020 model, by the way. 020, EDM 020. We're F7002. Okay, good. So fuses seem to be okay. Two things I could really do now. I could go around the board and check for voltages, or I can just quickly skim around some of the areas where I know I've had problems in the past and see if I maybe get a short on a cap that I'm not supposed to. When I say that, I mean a capacitor on a certain rail that is shorted to ground. So we should get a beep in continuity mode. We can then inspect further to see if that's a dead short to ground or not. If so, inject voltage, then see if anything is lighting up on the board with a heat cam, and if it is, remove it, destroy it, burn it. If not, well, we'll find out when we get to that point. I'll start around the F7002 area where the fuse is, and most probably speed this bit up until I have something a little bit more concrete. I really thought it might be this area because I've had shorts in this area before, but it's not this one. Okay. Okay. Right, so we have a short to ground here. I know that actually this is meant to show somewhere between 47 and 60 ohms on this line. It's caught me out a few times because my multimeter will beep anything below 50 ohms, and sometimes it will drop below that. But this is all good. So I'm going to keep in mind this area up here. So everywhere else seems fine. It's just here. Do we definitely have a short to ground? Yes, we do. It's coming up on my multimeter in continuity mode with 6 ohms. It's most probably not going to be the inductor, but the inductor is now going to carry the short from here into this chip. I believe, and I could be completely and entirely wrong, I think this links to the SSD controller IC. If I just go into regular ohms mode now, I'm going to see and just double check that it's definitely around about 6 ohms. Yeah, 6 ohms. Bear in mind my leads are probably 1 ohm, so you're probably looking at a 5 ohm short. What that does mean, and what I'm a little bit scared of here, is I don't want to go ahead and inject voltage. I was watching a video from Adamant IT, and he explains that if you don't have a dead short to ground, which is 0 ohms, you shouldn't really go ahead and inject voltage. So I don't know whether it's best to just remove these caps here, because that's just going to be really quick and simple. Take these caps off, see if that alleviates our short. If not, we could potentially look at lifting up this chip, but this could also indicate that our issue is with the SSD controller IC, which is on the other side of the board here. See, what I can do is just read these data lines, I believe, here in diode mode, which is actually red probe on ground and black probe on these little points to see if we get anything weird. This isn't going to solidify the fact that this is wrong, but I'm getting 0.5 in diode mode on each one. So I actually think that they're okay. I mean, it's okay so far. There could be, obviously, it might not be these data lines. It could be a plethora of different things. There's so many little solder balls under this BGA chip. Now, all of these lines are reading okay. 0.5 a piece. In which case, for simplicity's sake, let's just remove these capacitors here and see if that makes a difference. Like I said before, the alternative would be to just inject voltage. But I don't want to send voltage through to this IC, then to the SSD controller, and do more damage further. I mean, it might not even be connected to the SSD controller IC, but I have a feeling it is. So we're going to move the caps up just one by one. Sorry, not even one by one, just all at once. I can go ahead and just put them back. I just want to see if that's got rid of our short. Could have done it one by one. Would have built more suspense, I guess. Being honest with you, I don't think it is going to alleviate our short because, like I said, when I've had issues with this chip before, it's usually gone on to be something else. But I will double check. Here we go. Meters in continuity mode. Do we still have a short? Yes, we do. So we've still got a 5 ohm short. It rules out these caps, so I can put these caps back. I don't think it's going to be this inductor, but what I can do is if I move this inductor just up a little bit, I can tell if it's then on this rail or whether it's the rail on the chip itself. I guess the good thing with this beep on, beep off issue is that I've actually managed to find an issue on the board itself. Sometimes it just doesn't reveal itself like it has here. So do we have a short here? Nope. So it's a short on this rail here. We're still reading about 5 ohms. The board is still relatively hot, so that should climb back up only by another 2 ohms or so, but our short is here and not with this chip. In which case, I'm just going to turn it over, and if I turn it over, this is the exact area that's on that rail. I'm just going to measure some of these caps and see where that short is on the other side, because it should be here somewhere. I believe. Anyway, I could be completely wrong. All of this area is fine. Just for argument's sake, I'm going to remove the inductor off completely. Again, I know that's not probably the issue, because I don't think it's connecting to anything this end. So now I have absolutely nothing in this area, and I still have that short. Very interesting one. I've made another finding. This is actually behind the SSD controller IC. So the other side of this is that chip. If I go ahead and use my multimeter and measure just at the back of the IC, remember I said I wasn't going to inject voltage because we had a 6 ohm short. If I measure around here on some of these caps, not all of them, but some of them, I get a 6 ohm short. Therefore, I think that it is definitely the SSD controller IC that's at fault. Chances of one of these little components on the back being the issue, I think, are quite slim. I think it is more so the IC, but who knows at this point, honestly. I think my best bet is to just go ahead and remove the SSD controller and see if our short disappears from those caps where we were just looking at behind the SSD controller and also this rail here. I'm actually going to put these components back quickly. There we go. Like I was never there. Now we take the board over to the heater and remove this SSD controller IC. First off, we get the old thermal paste off of it. Not really the best angle, if I'm being 100% honest with you. This preheats the board to around about 300, 350 degrees Celsius. And then I come in with my hot air gun, which I have over here. We have another fan extractor here for fumes. Get our hot air gun up to temperature. Whilst the board is nice and toasty, I like to come in with some more flux and Big Bertha with a mix of leaded solder and just go over the board and get rid of that unleaded, or mix it at least with the unleaded that we have. Nice, there we go. Now give this a nice clean. Just using a cotton bud, get rid of all of this flux that we have. Whilst the board is nice and hot, the flux will come off easy. And there we go. That's a lot better. We don't have any BGA balls or pads, should I say, touch in here. So it should now give us an accurate representation if the short is gone. First off, for suspense, I guess, let's test the back of the SSD controller. Make sure that short is gone. Short, are you still there? Yes or no? No. Okay, so we're pulling now around about 500 ohms as a reading, which I'm going to guess is a lot healthier than what it was previously, which was 6 ohms. That's good. Yeah, okay. So this is actually ground, this whole pad here. The other side of the cap, I'm getting the 500 ohms. And the board is still hot, so that reading is probably going to climb. But that's good. Next obvious question then is, has our short gone from here? Yes, it has. Again, 550 ohms climbing. Probably will go up to around about 600 or so. I'm not too sure, but that's really, really good news. Now what we need to do is put an SSD controller IC on the back of here. I think I have one that I need to actually reball. Then we'll test to see if the short is back or not. Hopefully it's not. And then we should have a working PS5, but I could be wrong. Here we have the SSD controller IC all ready to go. It's all been balled. All balls look good. None are an incorrect size or anything along those lines, so we look okay. There's a little bit of flux on it, which is good. It's going to help when we put it on the actual board itself, but we might need to give it a thorough clean. Is that a little bit of solder paste there, actually, which could have been horrific. Get that off. Give it another quick once over with some IPA and a brush, just to make sure. All good, ready to go. VoiceOver Joey is here just to explain exactly what's going on your screen right now. When I removed the solder from the board of where the SSD controller IC is, it took off quite a lot of the mask that was next to the balls on the board. Now, whilst you can see that they're all pretty much connected to the same pads, there's no like pads that have been ripped off. What this means is that it can actually cause a shift when you go to put the chip on the board. The solder almost kind of spreads out and then it can make it uneven in certain places, and we can't really have that. So what I'm doing here is using conformal coating to cover up as much as I possibly can. Then I'll cure it with a UV light and we should be ready to go. If you don't get that temperature just right when you're removing the solder balls from the board, if you either apply too much heat or too little heat, you can cause this problem. I have created myself more work, but this is a job that I just want to ensure that we do 100% correct, which is the same as every single job we do. Chip is not on yet, it's not soldered, but it's been placed down, and I just need to make sure that I have the arrow with the arrow. This is now soldered, but I've made this mistake before and I do not want to make it again. So the arrow pin 1 is here. Just going to take it over to the heater now and solder this chip on. The board is still very much hot. However, I have cleaned up the area and the chip is now on securely in place. In a nutshell, do we get a short on the back of the SSD controller IC? If not, I'm excited. If we do, I'll definitely be having words with myself. Okay, how many ohms do we read here? Again, that's short, which is good for what we want. How many do we get here? Okay, I'm reading 70K, I think, which is better than what it was before. The most important place is this place. Do we have a short? No. Okay. We are reading on here 0.8K, which is 800 ohms. So let's see how this goes. Going to put it back together and test. Spoiler alert, I tested it without recording because I was very, very nervous. But it works. The PS5 works. Oh, I'm so happy. So what was just a pressing the button and beeping and not actually doing anything now actually turns on and works. I need to obviously put it back together and give it just a bit of extensive testing, make sure the previous profile was on there, etc., etc. But that is a happy Joey and hopefully a happy customer. This is now post Joey, and I can confirm that the customer was extremely happy. They've had the console now for a good couple of days. And everything seems to be working as it once was. Thank you so much for watching, and I will see you in the next one. Peace.